Hello everybody, my name is Mohit Deshpande, and in this video I want to introduce you guys to one particular subfield of machine learning, and that is supervised classification. And so classification is a very popular thing to do with machine learning, so let me actually define this. So classification is the problem of trying to fit new data. Or I should make this a bit more specific. I should say fit or label, new data based on previously seen data. This seems kind of like a weird description at this point, but with classification, the task is we've seen a lot of data and it's labeled. And given some new data, we want to give it a label based on some of the previously labeled data that we've seen. And I should mention that these are or I'll put it over here actually. I should mention that classification is, we have discrete classes or labels to each data point or input. And so let me illustrate this by an example. So suppose I have that was a really bad line. Suppose I have like a scatter plot over here or something. Let me just add in some add in some stuff here. So I'm just adding in a ton of red X's. Then we'll add blue circles over here. Okay, so this data is labeled, so these would actually correspond to actual points. So this for the X direction and this for the Y direction. These would correspond to actual points. I haven't actually plotted all the points, but trust me, they would correspond to actual points. And you see I've labeled them, and I've labeled them. There are only two classes. There is the red X and the blue circle. If I wanted to, I could add some other class, a green triangle. We'll add a couple green triangles or something up here. So there's three classes. We'll say there's three classes, and so I have all these points and they're labeled. And so the problem with classification is, now that I have these points, if I received some new point, what label would I assign to it? Would I assign to it a red X, a blue circle, or a green triangle? And so what we're trying to do with classification is to find a way and to build a model so that given this new input, we can actually assign it one of these labels. And so let's do like a human intuitive example kind of thing. So suppose my point that I'm going to put in, let's see, purple. Suppose my point was in here or something. Suppose this was my new point here. So with this being my new point, I would ask the classifier, what label should I assign to this? Should it be a blue circle, a red X, or a green triangle? And so if you as a human, if you were thinking about this, if I gave you this point and I asked you what would you assign it, you would say, well, I would assign it as a blue circle. And I would ask you, well, wait a minute, why would you assign it as a blue circle? And you'd say probably something along the lines of, well, if I look at what's around it, there are lots of blue circles around here, and it turns out that I guess this region of this region of the plane here tends to have more blue points, more blue circles here than red X's. So I can try to carve out this portion over here, I guess, is, this portion over here seems to be a lot of blue circles. So this is probably what I would assign this point. And so Okay, and it turns out that if you were probably to give this to a classifier, it would probably give this, a blue circle. Okay, so I say, all right. Now what about a point like over here? And so, well, you would say, well, I would give that a red X. And I'd ask you again, why would you give it a red X? And the reason for that is you give the same answer. You say, well, in this portion of, the I guess this portion of the plane over here of this given data, it's closer around that question point, around that new input. There's a lot of red X's, and so I would think that it would be most likely to be given with a red X. And so, right, that's right. And now, again, I can do the same thing where I say, well, what if I have a point like up here or something, and you'd say, well, this part of the image, this part of, or not the image, of the plane here, it is more, like this part over here, you're more likely to encounter a green triangle than you are any of these. And so I would probably give this point I would probably say that that new point should be a green triangle. And so this is kind of like the thought process that's going on with these classifiers. And so what you used to make your decision was this kind of, I kind of drew it in here, this kind of imaginary boundary sort of thing between our data. And so this is called the decision boundary. The decision boundary right here. And it helps us make decisions when it comes to supervised classification. Because we can take our point, and depending, we can take any sort of input data and find some way to put it on a plane like this, and then just find what the decision boundary is, and then we can plot this. And so with a lot of classification algorithms, what they try to do is they try to find this boundary is what they're all concerned about, is, because once you have this boundary, then if you get a new point, then it's fairly easy to classify, because you say, well, I want this portion to be, part of the boundary is blue, this part of the boundary is red, this part of the boundary is green. And so if you get points that are inside one of these boundaries, you just give it the label of what's around there. And so this is what supervised classification algorithms try to find, some kind of boundary. It might not be the case that you have such a nice two-dimensional data like this, but there are ways that you can like fit it onto a plane that I'm not really going to get into too much. But here's a question. So what if my point was like right over here, then it's not so obvious as to if it is a blue circle or a red X. And so, there's some inherent there's some confidence value or some measure that says that, I think this is a blue value with this confidence or with this probability. And so, like, even the points that we were classifying here, they did, even though that, it seems kind of obvious that around them they're blue circles, there's some inherent uncertainty about this. And it turns out that, well, for each of these points, there is a chance that it could have been a red X or it could have been a green triangle, but that chance was very, very low. And so we only assign it the label that has the, the maximum chance. So like it's not necessarily the case that this must be a blue circle. We say, instead we say, like, this is with a high probability a blue circle. And so there's no, like, you can't be 100% certain. And if you look at this point over here, it becomes clear that this could be a red X or it could be a blue circle. It just kind of depends on what this boundary specifically looks like. But given new inputs, I want to be able to like put them into these. I want to give them one of these labels here. So I guess this is where I'm going to stop right here, and I'll do a quick recap. So with supervised classification, it's a subfield of machine learning, and it's all it's the problem that we're trying to solve is we have these different labels and our input data, and we want to now that we've seen our data, we want to give it a new given some new input, we want to give it a label based on the labels that we already have. And so that is kind of the problem of supervised classification. So, we want to fit or label some new input based on what we have already seen before. And so I kind of gave this example of, if we had like red X's, green triangles, and blue circles, given a new point, how would you, figure out if it's one of these categories? And so like we use these things called decision boundaries to try to get that figured out. So yeah, so that is supervised. That is the supervised classification. There are tons and tons of algorithms that can do this. Some of them work well, better. Some of them work better than others, depending. It all depends on what kind of data you're looking at. But the point is that there are, there are lots of different algorithms for this, and so you can take a look around and see if there's one that you want to know more about. But anyway, this is the problem of supervised classification.